Multi-tank systems are very common because many people want at least 2 tanks so that they have redundancy if a tank were to fail. Also, shop fabricated tanks, commonly used for fuel, top out at 40 to 50,000 gallons, so larger fuel requirements need multiple tanks. There is some complexity to the design of these systems, so we wanted to take you through some of the details.
Most mission-critical systems require at least 2 tanks so that a primary and redundant source are provided. Since the tanks are monitored closely by environmental rules, there is always the risk that a tank will need to be removed from service because of a real or perceived leak monitoring issue. In some cases, potential fuel quality issues may dictate the use of multiple tanks. Multiple tanks are a design challenge because they require control of the selection of fuel supply source and also that return flows be directed to the same tank. Typically, a lead tank is selected manually and the secondary tank is activated when there is a low fuel level, a leak or a pump failure associated with the primary tank. The fuel system controllers must provide the logic for the tank selection and operation or the associated pumps and control valves. Solenoid valves are typically inadequate for control of fuel from multiple tanks because of their potential for leakage based on dirt accumulation on the valve seats. Actuated ball valves are preferred because of their tight seal characteristics and the ability to get feedback from limit switches on the valve positions. There is a danger in multi-tank systems of drawing from one tank and returning to another tank, causing an overflow. This danger is particularly acute for continuously circulating systems, such as boiler feed or filtration polishing systems, where small leakage rates through valves can accumulate into large crossflows. The primary safeguards are A. The use of proper tank selection valves, B. Controls that monitor valve position and alarm upon position failure, C. High-level sensors and controls that close return flow valves and stop operation when a high-level condition occurs. D. Where possible, a gravity overflow pipe between dual tanks. It is critically important for the valve systems to always provide an open return flow path from day tanks for overfill protection.